Yes, I have a good news. We have one abstract accepted to the Congress ISAE, the first one, and we will wait for the others.
Oh, gosh. No, not too much new news just at the moment. Great. Thanks very much, Andre, and thank you everyone for tuning in. And today I'm going to be talking about a couple of different things. Firstly, brigalow, birds, buffle, and bovines, and how we can try to integrate conservation with production in our world's grazing lands. Just before I get too far into it, I thought I'd introduce myself a little bit. I come from a dairy farm here in Brisbane, or just north of Brisbane. So I've grown my whole life, grown up for my whole life on a dairy farm, and am very, very passionate about sustainable agriculture from having that experience, I suppose. And I was lucky enough last year to work on some dairy farms in Germany, which is the photo on the right there, which was very interesting because it was incredibly different to at home here in Australia. And I'm also really passionate about biodiversity conservation and trying to preserve our really beautiful and natural landscapes, which is a very topical thing at the moment, particularly here in Australia, because a lot of our really unique wildlife, like the echidna that I'm holding on the right there, is currently experiencing really persistent and widespread declines right across Australia. And one of the main drivers of that is land use conversion from forest or woodland to pastures and cropland. So in Australia at the moment, we have this national reserve system, and it's not quite doing a good enough job to prevent our biodiversity loss. So even though there's quite a large area protected, you can see through this central part of Australia, this is the outback, I suppose, and it's a lot of desert and very, very dry and low productivity. Whereas our really productive environments, especially for agriculture, are in this eastern part, just through here where I've got the laser pointer at the moment, and then also in the southwest of Western Australia. And unfortunately, our reserve systems, particularly in this part of Queensland here, are really, really lacking and have caused a really big decline in species. So we need to be looking at options to conserve this biodiversity on privately owned agricultural land. And in the case of Australia, that's quite a good option because 45% of our total land use in the country is dominated by grazing of native vegetation, plus another 9% of modified pastures. So cattle grazing is our dominant land use here in Australia. And if we can work out how to get even just a small increase in the biodiversity value of that grazing land, that will translate across a really large area into quite a substantial impact. So before I get too far into the nitty-gritty of my project, I just wanted to highlight some of the similarities that have really jumped out at me in terms of Australia's grazing and biodiversity and Brazil's. The first is that the forest and woodland ecosystems in a lot of cases have been really reduced in extent. So in Australia's case, the Brigalow Belt, and in, I suppose, the case of Brazil, the Atlantic forest. And so when I'm talking about Brigalow forest, this is what I'm referring to. It's areas of acacia woodland that has a very, very high biodiversity value, but also grows on the very good soil. So our soil that's really good for cropping or livestock production. And you can see here which part of Australia I'm talking about. So this part of Queensland is the main part, and the black shows where this Brigalow grew before European colonisation in 1788. And to the current stage now, there's hardly any of that Brigalow left, and what remains is really isolated and small patches that in a lot of cases have become quite degraded. And from what I can understand, it's a relatively similar situation to what's happened in the Atlantic forest, where substantial areas have been cleared for agriculture and cropping since European colonisation as well, and that is ongoing, I suppose, in parts of the Amazon basin as well. The other links is that this clearing has occurred for either grazing, so beef production, or cropping throughout Australia. And it's been relatively recent. In the case of a lot of Australia's clearing, particularly throughout the Brigalow Belt, it's only happened within the last 60 years. So unlike parts of Europe, where the landscape's been cleared for hundreds and hundreds of years, in the case of Australia here, it's been relatively recent, which I think also aligns with some of the land clearing and agricultural development throughout parts of Brazil that have been relatively recent as well. So we're not dealing with a landscape that's been changed for 500, 600, 700 years. We're dealing with a landscape that's rapidly changed within the last 60 years. And finally, we're quite lucky because there's a really big opportunity for restoration of these ecosystems by retaining regrowth. So in the case of, to step through it, what it looks like in the Brigalow Belt, this is an aerial photo taken in 1967, and you can see this area had never been cleared before, perfectly remnant vegetation, and 12 years later, it's been very, very heavily cleared. And in particular, those high productivity soils. Where my pointer is now, this vegetation that hasn't been cleared is typically on the very poor soils that don't support much agricultural productivity, but also don't support very much biodiversity. It's typically our good Brigalow forest that grows on the good soil that supports our biodiversity. Then another 20 years later, you can see that a lot of the area has started to regrow. So particularly where my cursor is now, you can see it's become a bit more green and shrubby again. And that's because that Brigalow can come back by itself. And I believe it's a similar situation with many parts in the Atlantic forest from what I've read, that there's a lot of areas of the Atlantic forest that are naturally regenerating themselves. But that has a negative impact on the farm's productivity. This regrowth that comes through begins to compete with the pasture for nutrients, water, and light. And so the farmer will most likely clear it again. And that is what has happened. So in this particular landscape, this image is a bit more zoomed in, but it's been cleared again. But an exciting or something that is quite positive is that this time this farmer has decided to keep some little patches of this brigalow. So I highlight them just here. These are areas of pretty high productivity, good soil that they have retained in these small little strips and patches from when they've re-cleared the regrowth a second time. And so what we get is it going from this good remnant condition to open pasture with, in a lot of cases, very little shade value. And this is something that I'm very interested in trying to quantify, is for Angus, in this case, Angus cattle, with very limited access to shade resources, how provision of better tree cover throughout this landscape could improve their heat stress management and also their live weight gains as a possible benefit to the farmer. And then over time, it will regrow this brigalow vegetation and become like this. And you can see there's not much grass growing beneath. So we need to be able to work with the farmers to ensure that we're allowing some of this brigalow to regrow so that we can restore the endangered ecosystem, but do it in a way that's not going to negatively impact their farm's productivity overall. And just to give a perspective on the tree clearing in Australia at the moment, and particularly in Queensland, between 2010 and 2018, we saw nearly 2.5 million hectares cleared, but the majority of that was re-clearing. So very little primary rainforest or forest is being cleared now in Australia. Most of it's regrowth. So there's a possibility here to try to minimise some of that regrowth clearing to restore our ecosystems, but try not to impact our productivity. And especially as well, not to export any losses in production to another area. For example, if we reduced production in the Brigalow belt because we tried to restore the biodiversity there, we don't want to do that in a way that means the Western Australian wheat belt becomes a more intensive production system and loses biodiversity value there. So we want to really try to localise this production, I suppose. And again, a relatively recent paper that also came out of University of Sao Paulo shows that it's a similar thing happening in the Atlantic forest. We have wanting to restore these forests, but there's a high turnover rate. They're getting cleared again and again, and in some cases might only last about 8 years before they get cleared again. So it's incredibly relevant to both Australia and Brazil, this topic, I think. So our big challenge is, how do we encourage restoration without affecting our agricultural productivity and profitability? And one way to do this might be by retaining shelter belts and windbreaks of this native vegetation. So this is a landscape of some farms that I worked in central Queensland, where the farmers have deliberately kept these strips of vegetation in their paddocks. And I've also seen, I did some Google Earth looking yesterday, and this was in the Atlantic forest, I believe, and a similar pattern. I could find these linear strips of vegetation that have been kept, or in some cases, these little squares, which I found very interesting. So we have similar landscape patterns happening in both environments. But we also get landscapes like this in Queensland, where the farmer has decided to keep no vegetation. It's been nearly entirely cleared. And obviously that has really, really negative outcomes for our biodiversity. And I also found similar sort of situations occurring in parts of the Atlantic forest where no real vegetation had been kept within the paddocks. So why would these farmers, a couple of these farmers, choose not to retain any trees at all? Well, firstly, a lot of them can perceive that competition between their crops and pasture. The habitat these tree strips might provide for pests and weeds, and increased property management costs. For example, there might be a fire risk that they associate with retaining these trees on their property, or it might make managing their livestock more difficult, for example. But of course, we also have farmers that are keeping these strips voluntarily. And why might that be? Well, they could be getting improvements in their animal welfare and productivity due to shade and shelter. Possible increases in pasture and crop yield because those trees act as a shelter belt and a windbreak and reduce some of our evapotranspiration over that pasture. So our pasture stays essentially wetter for longer and lets it grow better. And finally, the emergence of carbon and biodiversity markets. Just last year, the Australian government announced a nature repair market where they are going to be putting money or encouraging private investment as well in biodiversity restoration that can be paid to farmers. So there will be an economic value put on this brigalow forest in the next couple of years. That means restoration of it could become a more economically viable option for some of these farmers. But before we get to that stage, there's a couple of key knowledge gaps we really need to be answering. Firstly, do these tree strips even give us a gain in biodiversity? A lot of them are occurring in really isolated or fragmented patches, and we were wondering whether these woodland species might even still use them, or if these patches have become too isolated and too degraded to even be used by our woodland species. Also bearing in mind that the cattle have complete access to these strips. They aren't fenced out of them, so they are using them actively for shade and shelter and foraging within them. Secondly, what factors influence the value of these strips to a variety of taxa and different species? Is it the width of the strip playing a really big role? Is it the density of vegetation? And finally, what are the expected returns and impacts on production that strip retention has on grazing businesses? So if I'm a farmer looking to retain some of this vegetation in the form of strips, I need to have the information available to me as to how it's going to impact my business's productivity and profitability. That's a really key step in amongst all this. So for my honours research project, I had 3 key questions. Firstly, do woodland birds utilise these strips of brigalow vegetation? Secondly, what are the key characteristics of these strips that affect the species richness and abundance of the woodland birds that use them? And finally, do these strips provide a beneficial zone of production in adjacent pasture? So do we get any yield increases because of having these strips present? And the region I was working in was Morven in the southern part of central Queensland. And this is what the strips look like. They have a good woodland with a very hard edge up against pasture. And that pasture is buffel grass. It's an African pasture species that's been introduced to Australia. So for my project, I surveyed 47 1-hectare sites within the strips. And I just did visual surveys with binoculars and also just listening to hear and identify species from that. So at this stage, I haven't deployed any audio or acoustic recorders. It was purely off-site. And we surveyed each site twice, once in winter and once in spring. And these photos give a really good example of how isolated these strips are, with pasture occurring all around them, and also the variation in their width. You see on the left, it's a very thin strip. On the right, it's a wider strip that this farmer has decided to keep. And I sampled a whole range of different widths from approximately 30 metres wide all the way up to ones that were approximately 400 metres wide. And within each of those sites, we surveyed the vegetation characteristics as well. So there were a couple of key variables that we were interested in looking at in how they affected the woodland birds that lived within the strip. The first was, did our strip occur in a landscape that had a high amount of habitat cover? So in the example on the left, we've got a lot of better than 50% habitat cover in this case, whereas to the right, there would be about less than 10% of that landscape covered by vegetation. We also looked at the vegetation status. Had it been cleared in the past and then regrown? And did that cause any difference in the birds that we found within those strips? We also looked at a particular species of bird, the noisy miner, and it's a species that is very, very aggressive and typically inhabits really disturbed environments, so urban environments, but also grazing environments where a lot of clearing has occurred. And previous research has shown where these birds are very high in abundance, they reduce the biodiversity of other woodland bird groups that are of conservation concern. And they can be really tricky to manage because they are a native species, but they cause a lot of issues for other bird species that are much more vulnerable and declining. We also looked at bufflegrass cover. Because it's an introduced species from Africa, our Australian birds haven't been able to adapt to eating its grass seed. And so areas that have high amounts of buffle cover, in a lot of cases, actually have very low habitat value for our native species of bird. And so we wanted to see whether that drove a difference. Did strips with high amounts of buffle cover in the understory have lower bird diversity than those with less? And the strip width we also looked at. This is a really important factor because for a farmer, a 30-metre strip is probably going to provide the benefits they want. It's giving their shade and shelter to their cattle, and it would be providing the windbreaking effect. And by making the strip wider and wider and wider, all that they're doing is probably losing more and more productivity beneath that strip as those trees compete with the pasture. But from the ecology perspective, we really want to know, do these woodland birds even use these really thin strips, or do they need the wider ones to minimize some of those edge effects that can really reduce the abundance of these fragmentation vulnerable species? To do the data analysis, we use generalized linear mixed models to try to work out which one of those variables was having the biggest impact on our woodland birds. And we did some model averaging procedures as well. And what we found was that a strip like this, even if it was quite thin, supported a really incredible range of different species of bird, which was really, really exciting. These are species that will only live in woodland habitat. They're not open pasture species, and they were still finding a way to survive in these quite thin strips. Just flicking through some of my favourites here. The mistletoe bird is the one on the left, a very nice and colourful bird. The speckled warbler here on the left is a vulnerable species. So to find it persisting in an environment with really heavy cattle grazing and still actively nesting and surviving was very, very encouraging. A lot of very small birds, really. And also quite a few reptiles that are quite unique to these parts of Australia. This is the blue-tongued lizard, which is a really cool species of lizard with his blue tongue, and a black-headed python, another really important species of snake in Australia. So we found that these strips were providing a really important habitat resource for these woodland birds, which was very, very encouraging. What we did also find is where there was lots of these noisy miners, we indeed got much lower biodiversity value from those strips. So that's a challenge for us to manage. And that's an area of ongoing research at the moment as to whether doing removal of these birds improves our outcomes for our species. And the other really exciting thing was that even a very thin strip supported the same number of different species as a wider strip, although in lower abundances. So we would find 4 different species in both a wide and a thin strip, but they were just in reduced density. So that's still a very encouraging result. These strips are allowing a good biodiverse range of species to survive in them. Now, to sample our pasture, we used the pasture transect method, where from the edge of the tree strip, we sampled out to 20 times the average tree height, because typically our wind breaking effect is a function of tree height. So for a tree strip that was 20 metres tall, we would sample 200 metres out from the edge of that tree strip. And that's us standing out in the pasture, looking back towards a strip, measuring how productive that pasture is. And this is during winter, so that grass has stopped growing, and that's why it turns that brown colour. During summer, it's green and growing and looks really good. And we're expecting to see a curve that might look a bit like this, where close to the edge of the strip, we've got really low yield that picks up as we head further away and then begins to drop off as we move further and further away from the edge of that strip. So we're expecting a couple of key zones. The first is the open pasture yield. This is what you'd expect to see if the tree strip was not there at all. This is beyond the effect of the tree strip in terms of wind breaking. So we've got a relatively stable and constant pasture yield in this area. Then we've got a zone of benefit where, because of these beneficial wind breaking effects and microclimate modification of the strip, we get our yield pick up. And then close to the edge, we've got reduced pasture yield. That's where our trees are competing with the grass for water and nutrients and light. And across the strips that we surveyed on the farms, we found a pattern that, for the most part, followed what we were expecting to find, which was very, very encouraging. You can see, particularly this one, this green one here, we've got a very big benefit zone where we're getting a higher pasture yield potentially because of that strip. So this is indicating to us that, yes, these tree strips are increasing our pasture yield in the paddock at least a bit. So to help visualize that, we've got low yield right beside the strip that's picking up and then dropping off as we head further out. Now, a big problem that still needs answering is the reduced pasture yield we have directly beneath the strip here. So my work was just sampling in this area beyond the tree strip. And so if you had a 30-metre wide strip, you'd expect to be losing, let's say, approximately 2 tonnes of dry matter of pasture per hectare. And as you increase that width, you're going to be losing more and more and more, but still having the same benefit zone, because a 30-metre wide strip will be providing, for the most part, the same wind breaking effect as a wider strip, we believe. So looking at the big picture with this, we know that increased demand for beef needs to be facilitated in a way that provides ecosystem restoration. And as two really big beef producers in the world, Australia and Brazil, I think we sit in a really good position to do this, especially as meat consumption is predicted to increase as the middle class grows. So we really want to be trying to meet that demand in a sustainable way. These strips do provide important habitat resources for woodland birds, and excitingly, they can benefit our pasture yield. So this means that these strips might represent a low-cost, high-impact vegetation management strategy. So going forward with my PhD now, after this honours project, I've got a couple of key questions that I really want to start looking at answering. The first is, okay, we've got an idea of how it's impacting our pasture, but we also really want to be looking at our animal well-being potentially, particularly in Australia where heat stress might become a problem. Well, it already is a problem, but it may become more of one as our heat wave events increase with climate change, and our productivity, our weight gains. If our cow's expending less energy on herself, trying to keep herself cool, she'll probably be putting that energy into gaining weight faster. Secondly, can we reliably benchmark farms or properties against one another so the right farms can access biodiversity markets? So we need to be able to go and look at one farm and their biodiversity and be able to say, okay, this is better than this other farm, and you are therefore in a position to be rewarded for that in an economic way. And this is going to bring up a lot of challenges, especially trying to compare between different farms that might have slightly different vegetation types or other underlying factors that could be driving that biodiversity. Thirdly, how much does that benefit that we got with our pasture yield offset our pasture productivity losses? So in that zone of competition and beneath the tree strip. So are we getting an overall increase in pasture yield because we've put that tree strip in place? Or is it staying much the same? Or are we actually losing a little bit? And finally, what is the best balance between tree cover and pasture for both biodiversity and agriculture? So to do this, what I'm really hoping to do is compare different landscapes with different amounts of habitat cover. So just to break this down, the blue line is our farm productivity, and that could be expressed in dollars per hectare or something like that, for example. We might be maximizing our farm productivity at a habitat cover of, this probably isn't the best example, but let's say around 50% between pasture and a treed environment. It's likely to be much lower than that. I just made this graph to show a relationship we might be looking for. And then our biodiversity increases, but we stop getting much of a gain beyond 60%. So increasing habitat cover beyond 60%, we're not getting that much extra biodiversity. So it's not going to be that worthwhile for our farmers to do. So we really want to find how big is the gap between where our biodiversity begins to flatten off and we're not getting too much more gain, and where is our peak in farm productivity. And if we look at that difference, that's the difference that's going to need to be made up for by things like biodiversity markets, and where there's going to be an economic value put on that biodiversity beyond production benefits like mitigating heat stress or improving pasture yields, for example. So I suppose my key messages from this is that the retention of strips in grazing landscapes could improve conservation outcomes whilst minimising impacts on pasture yield, and that retaining more of these strips throughout our grazing landscapes could facilitate widespread ecosystem restoration whilst maintaining food production at the same rates and not exporting it to other areas, which is really important. I was reading an article the other day about, you guys would know much more about this than I do, but enforcement of the forest code in parts of the Atlantic forest or Amazon, that could mean agricultural production gets intensified in other areas of Brazil, like the Cerrado or other areas that are also quite vulnerable to agricultural intensification. And we don't want to see that export happening. We want to try to keep it contained within these same areas for our restoration. So hopefully we can go from a landscape with relatively few strips and trees, not sacrifice much of our productivity, and manage to have a more balanced landscape with our biodiversity persisting alongside our grazing productivity for a healthy and sustainable beef production system. And these are just my acknowledgements for my university supervisors between the University of Queensland and the Department of Agriculture and Fisheries, which is run by the Queensland government here, and also the families of the properties that I was able to work on. So that was it. I hope, that was a good introduction, I suppose, to some of the production issues we're having in Australia at the moment. And I'm very keen for any questions. And yeah, I've also got questions for you guys about how you're working with measuring this animal well-being and finding this balance as well. So yeah, thank you very much. Thanks. Yep. Mm-hmm. Wow. Yeah, so this graph here, sorry, is this what you're talking about? Yep. This here is just something that I'm aiming to produce towards the end of my PhD. So this is not based off real data. I just made this just before, and a hypothetical. So that amount of habitat cover at which we get the peak of farm productivity, I think it would have been better if I had have put it back here. I think it would be more realistic around 30% cover, not as high as 50%. But it was more just to show this, trying to find this relationship between where our biodiversity begins to flatten off and where our productivity peaks. And yeah, no data on this yet. Where was that? Could you repeat? Sorry, I couldn't hear very clearly. Yep. Sorry. Yes, I see. No. This here's probably the best to look at it. So this was the distance from the strip edge as a multiple of the average tree height. So, for example, when our trees were about 10 meters tall, we were starting to get this benefit at about 50 meters out from the edge of the strip. So if I go to the other example that has all the raw data points, you can see this benefit was coming in by around about, if it was a 10-meter tall strip, about 30 meters out from the edge of the strip. If it was an even shorter average tree height, so let's say the trees were only 5 meters tall, that zone of benefit was about 25 meters away from the edge of the strip. So it varied depending on how tall the tree strip was, where we started to get that benefit zone. No. Yeah, so this is something that's really, really interesting. So no, there is no real legislative requirement at the moment for a total percentage that a farmer needs to meet on their property. There's recommended guidelines, and that was sat around about 30%. But a really big issue with this is that farmers, in a lot of cases, would meet that amount of habitat cover. If I go right back, where are we? This example here. So they would meet these, and it wasn't even legislated requirements, but these big patches of vegetation that have been kept are firstly very, very poor soil and very bad, like not very good vegetation. And so what has happened is, yes, they've kept this vegetation, but from a biodiversity perspective, it's not worth nearly as much as what these smaller patches of really good vegetation are worth. And so legislation came out about 12 years ago or longer, where satellite mapping of each farm was done. And they said any vegetation of this brigalow that was older than 15 years at the time of that mapping needs to be protected, and they can't clear it anymore. But the problem with the current legislation is that there's lots of brigalow regrowth occurring that's now older than 15 years, but these maps were made 10, 15 years ago, and the government isn't going to change them, because in order to get good trust and good relationships with the landholders, they're trying to offer a policy, and it makes sense, a policy that's stable and continuous throughout time. They don't want to be changing it. But the problem with that is that when this brigalow gets over 15 years old and it's starting to provide really good biodiversity value, it is still legal for the farmer to clear all of it. And so this is where we are really trying to work on these voluntary agreements where in landscapes that look like this, where the farmer decides by themselves they want to keep that vegetation because it's got the production benefit as well. So that's what we're trying to do there, not use legislative requirements that force them to keep it, but use these encouragement because it's going to give a potential benefit to production. Yeah. Yeah, and that's the other compromise that needs to be made. So a lot of ecology work, I suppose, often really encourages cattle to be completely excluded from these tree strips. But from the farmer's perspective, that's not really a good option because it firstly removes one of the big benefits of the strip in terms of shade and shelter. And it's incredibly expensive to fence all of these areas away from cattle. So yes, we are probably sacrificing some biodiversity gain by allowing cattle access to these strips, but we've got a much better chance of having farmers keep them if they know they can keep their cattle still within the strips. Yep. So I did a standard survey. So over 20 minutes, I would identify the number of different species I saw and the number of individuals of each of those species. So yeah, it would give me then a measure of the species richness and then the abundance of each of those species. Yeah. It took a long time. So it was done over about 6 weeks of field work split into 2 separate trips, one during winter that was 3 weeks and another during spring that was 3 weeks. And the way I would do it I would do the bird survey early in the morning during the best time of day for the bird surveys. And then in the afternoons, I would revisit each of these strips and begin the pasture survey work. But the really difficult thing about the pasture survey work was we collected the data. I'm trying to work out whether I can bring up a photo of how we did it. It was done using pasture quadrats and cutting the pasture to measure it. I have a photo if I can find it. All right, I'm just going to change the screen share. Okay, this should be starting to show some photos. If I bring up this video here, very blurry, but it's very blurry, sorry. But we would place a quadrat and then cut the grass. So it was very, very intensive, except it allowed us to get very, very high precision measurements. But for doing it over a bigger area now, we're looking at using drones. So there's been some cool work happening in Brisbane here using drones to measure pasture productivity and also pasture quality. So the amount of protein and the amount of fiber in that grass, so that we could potentially fly the drone over the whole paddock and get a yield estimate, sort of like what they've already been doing for a pretty long time now with cropping. and that sort of thing. Yeah. 47 sites. They were only on 4 different farms. Yep. Yes. Yep. Yes. Yeah, that's a really good question. And I think that yes. So in some of the vegetation, uh, that would be quite open and not very many trees. We definitely got, I think, fewer species in them, and particularly when we had a lot of this buffel grass, this pasture that would grow within the tree strips as well. A group of birds in Australia that's really threatened by this grazing and agriculture is ground foraging birds. And they're ones that rely on a ground layer that is made up of leaf litter with very little grass so that they can hunt insects and different things like that in amongst the leaf litter. And when we get this buffel grass grow right through, it really, really reduced the number of those birds. The other thing is that in the more open and expansive and disturbed vegetation, we also had substantially less birds because of those noisy miners, those other bird species that are incredibly aggressive and colonize these disturbed habitats. So there's a couple of different mechanisms all interacting and affecting the habitat for the birds. But the really good thing was at least the thinner strips, we were still getting those birds present. So we were still getting that biodiversity value. It would ideally require sampling over a long time period as well. So in southern parts of Australia, there are some experiments that have been running there for over 30 years. And there's a hypothesis, I suppose, that these bird species might only be surviving in these really disturbed environments because the clearings only happened within the last 50, 60 years. And over time, we might start losing them from those environments if we tracked it over a longer time period, which makes it more important that we start to increase the regeneration of these ecosystems as well. Yeah, so really good question. Thanks. No, it's quite amazing. They are a honey eater, so they visit flowers for nectar and small insects. But they just have this thing in their brain where they, for a very small bird, they're only about that big. They are just incredibly aggressive and force these other smaller birds. Those birds that I had photos of are in a lot of cases only about, like, I don't know, 10 to 7 centimeters big. They're very small birds, and so they are very badly affected. There's been some work done with culling, so doing a kill and removing them, but that has its own problems because firstly, they're a native species, so you need to get a permit to do that. And second, they were concerned that they would just recolonize and come back in again. So with some trial work they've done, and they're still doing ongoing work with it now, is that they're hoping after about 2 or 3 culls, they actually won't return for quite a long time. And the other thing is that these birds really don't like a good intact understory layer. So if I go back, to the PowerPoint, and so in this sort of forest, for example, I think it's slowly coming up. We've got a really good understory, and that's where those smaller birds are able to hide and forage, and the noisy miners aren't as big of a problem here. But when we get a lot of cattle or a lot of land clearing that opens up this understory, that's when these noisy miners will move in and cause a lot of problems as well. So there's been work done where they revegetate and plant shrubs in the understory to try to discourage the noisy miners as well. But it's an area of ongoing work right now. Great. Yep. Yeah, because I'm hoping to go and do this work with the animal